This is Agriculture Today. I'm Samantha Bennett with the K-State Radio Network. K-State's College of Veterinary Medicine hosted visitors from the land down under last week. Our first two segments of today's program feature Mark Hutchinson, a professor of medicine at the Adelaide Medical School, and two of his students, veterinarian and Ph.D. student Charlotte Johnston and post-doctoral researcher Dan Barratt. They share about their plans while visiting Manhattan, the collaborative research with the university on blood tests to measure pain in livestock, and the ways in which they hope to see this research grow. We end today's programming with this week's Milk Line segment from K-State dairy specialist Mike Brouk. Summer heat often causes somatic cell issues in the dairy herd, such as mastitis. And Brouk advises producers to check their treatment records to identify what types of mastitis were found, and to check with their veterinarian for available control options. That and more is coming up ahead on Agriculture Today. This is Agriculture Today. We are in studio now with three incredible guests out of Australia. They're joining us here for a special lecture here on campus at K-State. But we have with us Dr. Mark Hutchinson. He is a professor of medicine at the Adelaide Medical School. And we have two of his students here with us as well. We have Dr. Charlotte Johnston. She's a Ph.D. student and vet, as well as Dr. Dan Barratt. He is a postdoctoral researcher. So thank you guys so much for joining us today.
Thanks for having us.
Great to be here.
Thank you. Absolutely. So you guys have traveled a long way, like I mentioned, from Australia. And the main purpose is to speak at this inaugural COPIC One Health lecture that K-State's College of Veterinary Medicine is hosting. So tell us a bit about your experience of traveling the last several days and then coming to Manhattan.
Yeah, so we've come across from Australia on Sunday, and it's the first time that we've all left the country since COVID. Wow. Our borders are open again, which is spectacular, and it's a great opportunity to deliver the lecture that was supposed to be back in 2020 on a project that we started back in 2020 with the school here, and we're really excited to see where the project's come to so we can actually talk more about the project because it's now official. We've started to generate some data, and our work on the Australian side has progressed as well.
Absolutely. So as postdoc students and PhD students, what has your experience been like? Obviously, this is your first time leaving the country as well and coming maybe to the U.S. for the first time?
Yeah, it's my first time in the U.S., first time in North America. So it's, time difference, and it's been interesting, but got to have a nice walk around the place yesterday, which was really nice to get a lay of the land and explore the campus a bit.
Yeah,
excellent.
It's beautiful seeing the prairie too.
Oh my goodness, yes. I'm new to this area as well myself. I'm from Alabama originally, so the Konza Prairie has been one of my favorite aspects of moving to Manhattan. It's beautiful.
Yeah, and I guess walking around campus, we have very big universities in Australia, but we do not have the sports that go along with them. So we're excited to go to the game on Saturday and experience the whole experience of being on campus with the game. But yeah, in Australia, we have our professional sports and then we have amateur university leagues. So Dan used to play Australian rules football for the Blacks team for the university. But yeah, I think it's a different world over here with that level of alumni engagement and competitive spirit.
Absolutely, yeah. Well, that'll be such a fun experience to get you guys out to a football game and see all the hubbub. Students get so excited. I have interns in the studio right now as well, and I'm sure they can attest to that. They really enjoy their Saturdays on campus, but it'll be cool. Are you guys going to get to tailgate any?
We are going to tailgate. There's at least 2 or 3 versions that we'll be going to. So, yes, we've been being entertained extremely well, and it's been the generosity has been spectacular.
Good, as it should be, traveling this far. I know K-State has been very welcoming for me, so I'd hope that'd be the same for guest lectures. So that's incredible. Well, like I mentioned before, you're here really for this guest lecture. That's the main sole purpose that's been hoping to go on since 2020. But it's because of this project, like you mentioned, that's tying into partnering with K-State and the College of Vet Med. And it's really astounding research that you guys are doing. It's taking these biomarkers, their blood tests for pain. And you've done the research in human medicine, from what I understand. That dates back to your Ph.D. days.
So literally 2 decades ago, we made the first measurements of pain accidentally in blood. I was part of a clinical trial. We had a range of people who were experiencing different amounts of pain. And I was doing the immune cell phenotyping, the checking how their immune cells were functioning. And we found this amazing relationship between how much pain they reported and their immune cell function. And we were literally a decade ahead of our time to actually understand how that worked. And it's taken 2 decades to actually realize this could be a technology that allows for humans to understand how much pain someone's in. That's really important for even everyday people who can say, out of a scale of 1 to 10, how much pain are you in, to be able to validate that result with a blood test. But then also it's really important in children, in the aged, who perhaps don't have language or have lost their language because of demented state or perhaps unconsciousness. And for what we're doing here, animals. We aren't Dr. Doodle yet. We can't speak the language of all the animals. So can we actually use molecular tools, literally at the nanoscale, to make these measurements and predictions of pain state? And so we've started that work in the humans, and we're literally flipping that to do that work in the livestock, so that then if we can create that at the moment, a laboratory-based test that takes a lot of time, takes a lot of money, but really then actually making that almost like the rapid antigen test for COVID, the equivalent of that for a very small amount of blood. Can we then create that technology to then make a measurement real for both livestock in the production setting, maybe high-value animals, but also then in abattoir? So can we assess every single carcass coming through, has this animal had a pain-minimised life? And therefore, could we achieve a premium price market for clean and green, high-quality product, excellent eating value, but then also high ethical well-being value as well to achieve sustained market access? And then if we can do that in animals, let's do it in humans. So let's flip that rapid test technology back into humans. And so this is this joint force activity between us and you here to enable that technology to come to adoption and extension.
Wow, that's incredible, honestly. I mean, so obviously it's a multifaceted area of research, like you mentioned, not only the contributions that were found originally in humans, and now we're thinking, well, how can this benefit our livestock industry? And then how can we tie that research back into humans? It's incredible. And part of that is the overall theme is animal welfare is the motivation. But ultimately, when we include animal welfare and improving that in our practices, we ultimately increase productivity. We all know that.
Absolutely. And I guess from the human setting, we know that people in pain contribute about 30% less to the economy because they can't work. They actually consume more medical requirements. And obviously here in the US, especially with the opioid epidemic, massive societal and community loss of life because of use of opioids, which actually is underpinned by the inability to truly understand what the pain is. In the production setting, we know that animals in pain have a negative affective state, not anthropomorphizing anything here, but just saying their brains look a lot like a depressed human brain. Therefore, we're not saying the animal's depressed, but we know it's in a negative state. We also know that pain is associated with increased infection rates and increased susceptibility for infection. There's a change in the metabolic nature of the animal, meaning that they're not spending more time of their energy to go into creating muscle mass and hence protein product. It's actually just spinning the wheels of keeping the animal alive, which is not what you want when you're dealing with productivity. So we think there's a massive unrealized productivity boost by creating animal opportunities for a decreased acute pain, but critically also the chronic pain, which we have not explored yet really in livestock settings. And then that we think will come back in to then have a productivity gain on literally meat on the bone, but also the quality of that meat on the bone.
Absolutely, yeah. It's similar to kind of those why we minimize stress oftentimes in our animal handling practices, the same kind of thought process, but actually tracking the pain. It's incredible.
Yeah, so that low-stress stock handling we use extensively in Australia, and it's this mystical ability of an individual to be able to be good at low-stress stock handling, and people wear it as a badge on their sleeve. They're really quite proud of that. And I absolutely advocate for that low-stress stock handling. Where we're trying to come in then is saying, can we objectively measure whether what we understand today is actually the best low-stress stock handling? Are there other practices that we could actually apply and say, here is the pain state, here's the stress state of the animal? Are there extra things that we could do? And some of the work that we've started exploring is actually in and around the weaning time. And are there things that we can do to augment the weaning experience? Because that period of time in all animals' brain development is actually when the emotional centers, the limbic structures of the brain are developing. If we stuff things up there, we end up with a brain trajectory of development that's not the same. So can we actually augment that to create the best brain possible that then no matter what life and environment throws at human brain, animal brain, the brain can actually function best and not respond in an overstressed, maladaptive, poor response way, but actually good stress. And I think that's the other part that we're learning more about is there is actually good pain and there is good stress, because good pain is, oh, that hurts, I'm not going to do it again. We learn from it. The stress response acutely, that is often good because there's metabolic changes that actually protect us. It's the long-term consequences that we don't want. We don't want long-term stress. We don't want long-term pain. And if we can understand those more through these objective measurement tools, then we can start creating opportunities to stop that or mitigate that.
Wow, incredible. That's awesome. With that being said, this incredible conversation does not end here. We are about to have to cut to a short break here, but when we return, you'll hear more from Mark Hutchinson and his students Charlotte Johnston and Dan Barratt from the Adelaide Medical School. They'll share more about their specific roles they play in this incredible research team, Charlotte providing vital insight as a veterinarian, and Dan in the laboratory. They also share their vision for where they see this research going in the future and its actual use, and the hope of continuing collaboration on many potential future projects with researchers here at K-State. We end today's programming with this week's Milk Line segment from K-State dairy specialist Mike Brouk. Summer heat often causes somatic cell issues in the dairy herd, such as mastitis, and Brouk advises producers to check their treatment records to identify what types of mastitis were found, and to check with their veterinarian for available control options. That and more is coming up ahead on Agriculture Today. This is Agriculture Today. We are now continuing our conversation with Mark Hutchinson, Charlotte Johnston, and Dan Barratt from the Adelaide Medical School on their research in collaboration with K-State, looking at blood tests to measure pain experienced by livestock. Working on this sort of research that you know is going to be so impactful, what an incredible experience. Tell us a little bit about that. Yeah,
it's really exciting. I've been working as a vet for 5 or 6 years when I came across these projects, and I thought it was really interesting, so I moved from the UK to Adelaide to get started and learn a lot more about trying to diagnose pain in an objective way, and ideally easy using blood test, which would be great.
And it's been really good to have Charlotte as a vet on the team to actually start saying, me with my academic boffin hat on, this would be awesome. And she'd say, no, that's not going to work. Because, simple things like our current work in Australia is on sheep. We're looking at how we actually roll these studies out in beef cattle. We've been operating in and around the rear end of the tail-docked and castrated sheep. And that's not a problem because they're, maybe 60 to 70 kilogram animals by the time we're processing them. We're not getting round the rear end of a decent-sized beef cattle just because we want to keep our heads and hands intact. So that's been really interesting to sort of try and blend those two together. And also, Charlotte's been a Jillaroo on stations and done all that work as well.
Yeah, who better to speak to the practicality of some of these practices than someone who's been working in that field for years and actually knows, hey, that's a great idea, but like you said, I don't think that's the most practical for the situations I'm often in as a veterinarian.
Yeah. But it's been great been trying to work together and figure out, the best way of coming to finding the best measurement for these sorts of trials that we're running. Yeah.
And then being able to actually go in and this is the spinal cord, and so Charlotte's, done a lot on the outside, now coming onto the inside she is now the awesome spinal cord removalist that we have. We now learn from Charlotte as to how to do that.
Excellent. Well, Dan, I know that you've also played a key role in a lot of the analytics on this side of things, so tell us a bit about that.
Yeah, so it's an interesting challenge, and each new data set that we create is a completely new challenge, and that's what makes it really exciting. And I think coming from my previous experience, which is very much lab-based focused, into a team where we have all these diverse views, and also what's been really exciting is having direct communication with the end users as well. And so really I see one of my key roles is actually to adapt and customise our analysis approach to really move towards and think about and be focused around what is the end use going to be. Because there are, we have some very standard analysis pipelines that we might apply to transcriptome data, things like that. But really, I just see my role is adapting that to answer the questions that the end user wants answered. And I think that's really exciting because it gives me great direction and license to go out there and try new things, find new solutions, and I find that really exciting. And having that support and justification for this is the target that we have, this is where we're trying to get with this, and it's not just an exploration.
Absolutely. So end user in mind, where do you hope this research really leads? Do you hope it's a product that individuals can use?
So as part of the program of work we're doing here with the colleagues, it is driven entirely by the FDA's need. The FDA's need to have an objective way to assess all future livestock targeted therapies to say, is this drug working or not? And that's previously being done by looking at the animal's response and using our intellect to say, yeah, that looks a bit better. The problem is, going back to this point, we do not speak the language of the animal. And some of the work that Charlotte's actually sort of broken down is we are predators. Most of our livestock species are prey. They have evolutionarily gained the ability to hide things from us intentionally, one of those being pain. And so using our more human-derived assessment, quantitative sensory testing, and these new molecular tools, we're actually breaking apart that actually after a procedure of husbandry practice, castration, dehorning, tail docking in sheep, this actually does hurt, and it hurts for longer than we'd previously appreciated, which means now for the FDA, what drugs actually work the best? And can a recommendation be said, objectively, drug A works better than drug B if you're in this particular setting? So use that. So that will be a laboratory standard tool for the FDA to use. But parallel to that, we're doing the technology development for a deployable rat test for pain, which will be deployed for producers and vets to actually use out in the field. And if we get it to work for livestock, let's use it in small animal practices, large animal practices to understand the pain states, which then allows us to then intervene more beneficially with better drugs. And that then leads to the abattoir setting for the protein products, where we've already got two technologies in Australia in abattoir that at line speed is now objectively measuring carcass quality. So previously, Australia has set up the Meat Standards Australia practice for eating quality, which was a combination of subjective measures with some objective pH tissue measurements, for example, to assess the carcass quality. A single cut within the meat was to assess the entire carcass of a beef cattle, for example. That doesn't include every single cut. Our technology uses the world's smallest microscope in a needle, operating at line speed, which will allow us to then assess the eating quality of every single cut off of every single carcass. That is a huge optimization to the process, meaning that the best cuts are going to the best places. It also means that that data flows back into producers to say, these are the genomic selection traits we should now go for, objectively measured for all of these cuts, for example. So that's happening parallel to then the human development work. And that's where we really see the livestock community taking the leadership role in addressing welfare and well-being for animals, which will then pay dividends back in human medicine. So literally, producers can say, this is awesome. We are helping our animals and the whole of the global human community through the addressing of measurement of pain.
And it's funny how those things work out typically when we think of this work, especially done in veterinary medicine. That's why this One Health perspective, this initiative, it's so important because it's the work we've already been doing, I feel like, in that field anyways. But now we're just putting a stamp on it and being like, this is why our contributions go beyond just what we do as veterinarians in a lot of cases.
Yeah, and I guess past experiences where I've seen this happen in Australia is in the IVF field. So Australian IVF was developed out of cattle embryo development. And all of the early in the 80s, all of the media and the various techniques for fertilization for human babies was based on cattle work. So there is a good precedent here of IVF leading to great productivity gains for the industry, great outcomes for parents who weren't able to conceive by themselves. Can we actually repeat this, 4 decades later now with a pain test?
Absolutely. Wow. Incredible. So I know we've talked about, you've come to the U.S. for this lecture and you're going to go to a K-State football game, which is super exciting. But outside of those two events, what else are you looking forward to most about your visit? Yeah,
so next week we're actually also then going to the World Congress on Pain in Toronto. So the International Association for the Study of Pain has their World Congress every other year. Just happens to line up perfectly with this. So we're all heading over with 2 more of our colleagues and about 2,500 other pain geeks to talk about not only human pain but also non-human pain, so animal pain as well, to understand more about the fundamentals of what pain is, what is the best way to measure it, what's the best way to talk about it, but also how do we actually then treat it. So we're doing that, and we are also seeing a lot of other colleagues across the campus where we can see direct alignment with what we're doing at the University of Adelaide and in Australia to create a greater connectivity between the two countries. Many of the listeners might be aware of the AUKUS partnership, which is the UK, US and Australia working really closely together on new both strategic government economic developments, but also on defence ties. So we're buying a few of your submarines, for example, for a few $1 billion each. There needs to be greater connectivity. So we also do a large amount of defence research as part of our program. We need to understand nuclear medicine more, radiation safety, because we don't have nuclear power or any of that type down in Australia. We need to learn from you, and you have that capability here. So why reinvent the wheel? Let's partner with friends to do it faster.
Sure, and likewise, so much we can learn from you all as well, especially obviously in regards to this area. As far as the partnership with K-State, do you hope to see this continue on in other research areas as well?
Absolutely. So we've already, over some very nice local food, already talked about at least 5 different projects that we want to be opening up. So South Australia has one of the most progressive cannabis laws in Australia, where we then have production of cannabidiol-producing plants. We see a really exciting opportunity to advance that program of work. And who's done the best work in the States? It's right here. So can we actually learn from each other there? There's some other unique processing abilities around those drug extractions that we think are worthwhile exploring, as well as a range of other well-being, welfare-related projects that we're doing across pigs and through to other conservation species.
Wonderful. Well, I look forward to hearing about all of the research to come, and especially the results of this study as things get more solidified and the results come out more and more. But I really can't thank you guys enough for carving time out of your busy schedule and this visit to come and speak with us today.
Well, thank you, and hopefully we can welcome you to Australia at some point now that our borders are open.
Hey, I would be totally down for that. Ag Today on the go. I would sign me up. But thank you each so much. I really do appreciate your time.
Thank you so much.
Thank you for having us.
Absolutely. Once again, that was Dr. Mark Hutchinson. He is a professor of medicine at the Adelaide Medical School, as well as Dr. Charlotte Johnston. She is a Ph.D. student and veterinarian. And Dr. Dan Barratt, he is a post-doctoral researcher. They are all on a team of researchers looking at blood tests for pain management in livestock, but also tying that research back into humans. Once again, we will be back with more on Agriculture Today.
From Kansas State University, this is Agriculture Today. Along with Samantha Bennett, I'm Jeff Wickman. We end today's program with this week's milk lines. K-State dairy specialist Mike Brouk says that summer heat often causes somatic cell issues, such as mastitis. He encourages producers to identify what types of mastitis they've seen in their herd and to consider options for controlling it.
Today I'd like to visit with our Kansas dairy producers concerning somatic cell counts and some of the issues we might be seeing as we come out of summer. Most of you have probably been watching your somatic cell counts slowly rise over the summer months, and this is normal on our dairies as we have an increase in heat stress. We also have a situation where cows' immune systems are less able to fight off infections, so a slight rise in somatic cell count over the summer months is not unusual. Also, the bacteria that cause many of our somatic cell issues in our dairy, i.e. mastitis, grow quicker in the summer during the warmer weather. So, as you look at your somatic cell count, what types of mastitis are you dealing with? Well, unless you've been doing bulk tank cultures, you probably really have no idea. So one of the things I would encourage you to do is sit down with your veterinarian, or if you use someone else to monitor milk quality on the farm, they should be part of the discussion as well. I would encourage you to, number one, get some bulk tank cultures to see what types of organisms that you're actually dealing with. It's usually best to collect some samples over a month or so and maybe do some composites so we don't have quite so many samples to send to the lab and get those checked out. Next, I would start looking at your treatment records for the last couple of months and the number of animals that you have treated for mastitis issues. So a couple of things that I think are important to note there. Number one, what lactation were those animals when they came down with the mastitis? Is it just in your heifers or is it spread across the herd? What pens are these animals residing in when they come down with a clinical case of mastitis? What stage of lactation are they? Are they early lactation or late lactation? Once you've collected some of this data, if you have some individual cow samples that have been submitted for culture data, it's important to pull that data into the discussion as well to determine what types of organisms have actually been found in the cases of mastitis on your farm. Now, as you sit and look at the data, you need to divide things up. Are we dealing with contagious mastitis? You'll get that from the bulk tank culture data as well as the individual cow samples that you've taken. Or are you dealing with environmental mastitis? As we think about summertime, a lot of times we're more likely to see environmental cases, things like Klebsiella or E. coli. And some of these can be very toxic to the cow, so maybe you've even lost a cow or two on your farm due to these over the summertime. If we're dealing with E. coli's and if they're causing a significant number of cases of mastitis in our dairy, probably need to look at our vaccination program. Along with our veterinarian, may have to make some modifications there, as there are some changes in what we sometimes recommend, particularly if we're seeing larger number of cases of E. coli mastitis on our dairies. Now, if you're dealing mostly with contagious pathogens, and a lot of times this will be things like Staph aureus, could be mycoplasma, but probably Staph aureus is the one. Treatment is generally not very effective against that, so you're going to probably have to consider culling some animals or placing some animals in quarantine, if you will, on your dairy so that they're milked from a separate pen, and that pen should be milked last in the milking order. Sometimes solving these issues with somatic cell can take a lot of time and a lot of expertise. So make sure you ask for help. There's excellent resources here at Kansas State University to help you with that, both in our animal science department as well as across the way in our vet science department. This is Mike Brouk with K-State Research and Extension, encouraging our Kansas dairy producers to carefully consider what options they might have for mastitis control on their dairy.
Thanks, Mike. And that'll do it for the Tuesday edition of Agriculture Today. For Samantha Bennett, I'm Jeff Wickman. This is the K-State Radio Network.